Welcome to the LOD2 Stack Statistical Use Case Demo. What we'd like to show through this demo is how mature the LOD2 stack is for tackling the process of moving from raw statistical data to globally visible rich collections of interlinked open data. In our scenario, we'll be taking you through a number of crucial steps in that process. Before we get to the actual data, we shouldn't forget that without the metadata that accompanies it, statistical data can often boil down to nothing but a bag of numbers, so to speak. Luckily, the LOD2 stack has all the means needed for dealing with metadata. Take, for example, the pool party taxonomy editor. Here, we have a number of code lists used to describe the data published by the Statistical Office of the Republic of Serbia. The ESA 95 code list, for instance, contains the codes used to denote the most common statistical indicators. Now, if we take a closer look at this code list the Serbian Statistical Office uses to describe different geographical regions of Serbia their data covers, and pick a region such as Novi Beograd, which is a part of Belgrade, we'll see there is not much metadata describing it. A code and a label is all we have here. We see there's a link to a related concept though, which is the city of Belgrade. But this concept doesn't have much additional information either. What Pool Party gives us, apart from a great way to organize these code lists, is a way to enrich them using the information found in the LOD cloud. So we click Link to LOD, and immediately we can retrieve recommendations from DBpedia related to our concept. And this is really great if we want fine-grained metadata management, where we're not dealing with a large number of concepts. But what if we are dealing with a large amount of messy data? What about batch processing? This is where the LOD-enabled Google Refine kicks in. What we have here is the code list you saw earlier. The name mod column is a modified name column, holding a filtered list of names of Belgrade municipalities. We've cleaned it up in hope to improve accuracy during the reconciliation process. We reconcile by simply choosing the reconciliation service, then picking an entity type, here we're choosing DBpedia's populated place concept, and clicking Start Reconciling. After the process is done, we can see that our new column has been enriched with additional information from DBpedia. Let's take another look at the region of Novi Beograd, which we saw earlier. Clicking the link gives us the corresponding DBpedia entry. Now, onto the actual data. In our scenario, our input data comes as XML. The stack has a built-in XSLT processor for transforming this kind of data. We simply pick our input file, the XSLT transformation file, and the catalog file. Choose the graph we want the data to be added to. Here we create a new graph and click Upload to RDF Store. The results can be seen immediately. This is our RDF graph. The graph we created in the previous step holds the information from two datasets published by Eurostat and the Statistical Office of the Republic of Serbia related to broadband internet coverage in different countries of Europe and Serbia respectively. Imagine you needed to quickly compare that data. We all know how difficult writing SPARQL queries can get. SPARQL is the latest addition to the LOD2 stack that makes this task a whole lot easier. Yes, it provides syntax highlighting, but this isn't new. What's new is that it relies on a so-called data summary graph, an underlying statistical structure that enables it to provide context-aware recommendations and auto-completion. All we have to do is start typing, then press Ctrl space, and SPARQL will provide us with a number of options available for that position in the query, speeding up the task of query writing significantly. Once done, we click Submit, and the data is retrieved. Now, let's take a closer look at that graph. Thanks to Anto Wiki, even non-experts can go into the details of any dataset. For instance, this is the data structure definition instance describing our dataset. If we dive into the region dimension of our statistical data cube, we can see it fetches its values from the code list we created earlier. If we'd like a better visual representation of the actual data, Thanks to another new addition to the stack called CubeVis, we can simply pick the values we're interested in from the available dimensions, then click on Select Data, and what we'll get is a colorful representation of that bag of numbers we started with. Finally, the publishing process. All of our transformed data is made available online via the Serbian CCAN data catalog. So let's see what information is already there on Serbian national accounts. The very first result in the list gives us a detailed description of the domain, some resources, and some additional metadata. If we'd like to see what other datasets there are carrying the same tag, we simply click on the tag and then get a list of other published datasets. If we choose the GDP dataset, we immediately get related information, including the resources such as the Excel sheets, RDF dumps, metadata on the domain, temporal and geographic coverage, publisher, maintainer, and so on. The really great thing is that this data is being harvested on a periodical basis by Public Data EU. Here's the same dataset on the European data portal, meaning the visibility of the original data has been vastly improved. Thanks for watching.